Hello students and welcome to today's session. In this lecture we will study a very important topic, marking and measuring tools. Marking is the first step in the machining process before we start any actual cutting work. We must perform accurate marking. This helps us transfer the design onto the workpiece correctly. On the other end, the final step of the machining process is measuring the finished product. To check whether it has been made according to the prescribed dimensions, so today we will learn about both marking tools and measuring tools, their importance, their types, and how they are used in practical situations. Let us begin with measuring gauges. Measuring gauges are widely used in laboratories and workshops to measure the internal and external diameters of different objects. There are mainly two types of gauges, manually operated gauges and digital gauges. In this chapter, we will focus on two commonly used manual measuring gauges, vernier calipers and screw gauges, also known as micrometers. A vernier caliper is a widely used classical measuring instrument. It is used to measure the internal diameter, the external diameter, and the depth of cylindrical pipes or any other components. It is very precise instrument capable of measuring up to 1/100th of milli or 1/1000th of an inch. Since it is a precision tool, it must be maintained properly. A vernier caliper should always be cleaned with a dry cloth or with the cloth dipped in cleaning oil to avoid dust, rust, and measurement errors. Here I am adding a short clip related to vernier caliper.
In this exercise, you will learn how to measure and calculate the outer diameter of a cylindrical tube using vernier caliper. Adjust the movable vernier scale to close the outer jaws of the vernier caliper. The outer jaws should be fixed on the outer circumference of the cylindrical tube. Note down the centimeter graduations on the main scale to the left of the zero graduation on the vernier scale. Here it is 40 millimeters on the main scale. Note down the millimeter graduations on the main scale that is just left to the zero graduation on the vernier scale. Here, it is 4 main scale. Observe along the 10 graduations on the vernier scale and the millimeter graduations on the adjacent main scale. You will find a line on the vernier scale that coincides straightly with a line on the main scale. Here, it is 0.4 millimeters on the vernier scale. Now, to get the measurement, just add the above found 3 readings. Here, the outer diameter of the tube is 40 plus 4 plus 0.4, which equals 44.4 millimeters.
Next we have the screw gauge, also called micrometer. This is also a high precision tool. The screw gauge is mainly used to measure the outer diameter of wires and thickness of metal sheets. Due to its screw mechanism, it provides a very fine level of accuracy for small components. Let's look at a few important application points. The vernier caliper is externally extremely precise. Its reading error is 1/20th mm, which means 0.05 mm. To measure the internal diameter of a hollow cylinder, the vernier uses its inside jaws located at the top left. These tools help us ensure that the components are built exactly as required. For better visualization, have a look of a short clip related to screw gauge.
Screw gauge is an instrument used for measuring the diameter of a thin wire or to measure thickness of a metal sheet. You will now see how to use the screw gauge. The parts of a screw gauge are shown above. It consists of a U-shaped frame fitted with a screwed spindle, which is attached to a thimble. The distance moved by the spindle for one revolution of the thimble is called as the pitch value of the screw gauge. In standard screw gauge, one revolution covers 0.5 millimeters on the sleeve, which is called as the pitch value. Finding the least count. The least count of the screw gauge can be calculated using the formula shown. Here, the least count is 0.01 millimeters. Checking for errors. Now, slowly tighten the thimble by rotating the ratchet such that the end of the anvil and the spindle touch each other. Zero error. In zero error, the zero of the circular scale will coincide with the zero on the datum line of the sleeve. Positive error. In positive error, the zero of the circular scale will not cross the zero on the datum line of the sleeve. The error value multiplied with the least count is subtracted from the final value. Here, the error value is 0.02 millimeters. Negative error. In negative error, the zero of the circular scale will cross the zero on the datum line of the sleeve. The error value multiplied with the least count is added to the final value. Here, the error value is 4 times 0.01, which equals 0.04 millimeters. Measuring the radius of the wire. Tighten the ratchet, keeping the wire in between the anvil and the spindle end till you hear 4 or 5 tick sounds from the ratchet. Observe the graduations on the linear scale. Here it is 4.5. Now, observe the graduation on the circular scale that coincides with the zero line of the linear scale. Here it is 6. The formula for obtaining the measured value is shown. Now, you consider that the last screw gauge has zero error, so the measured value is found to be 4.56 millimeters. You have learned how to use the screw gauge for thickness measurement.
Now let's move to the next part, marking tools. Marking is a process of transferring a design to a workpiece. This is the first step before any manufacturing process. The actual dimensions that are going to be machined are obtained only when the required markings are made correctly. Some commonly used marking tools include scriber, punch, divider, marking knife, and others. In this section, we will look closely at two main tools, scriber and punch. A scriber is a pointed, sharp tool made out of steel or carbon steel. It is used for scribing or marking lines on the surfaces of a material before cutting. Scribers are especially useful on surfaces where pencil markings are not visible or may get erased easily. For example, on hyaline or bakelite sheets. There are two types of scribers, plain scribers, double-ended scribers. A punch is used to make punch marks or some small depressions on the locations where drilling or cutting needs to be done. It is made of hardened steel and has a narrow tip. There are two main types of punches, center punch, prick punch. Center punch, it has a larger angle. The punch mark is wide but shallow. Prick punch, it has a point angle of 30 degree or 60 degree. The 60 degree punch is used for creating witness marks, while the 30 degree punch is used for light marks used to position dividers. Punches also have special applications. Decorative punches are used to create images, logos, or punch on metals. Letter punch are used to emboss letters or on metal surfaces. Let's watch a small clip related to Scriber and Punch.
In this media, you are going to learn about marking tools like Scriber and Punch. Let us start our discussion with Scriber. A scriber is a pointed, sharp tool made of steel or carbon steel. These are used for marking lines on the surface of the workpiece that is about to be machined. They are also used for marking on such surfaces on which pencil marking is not clearly visible or gets erased easily. Plain scriber and double-end scriber are the two types of scribers used for marking. Plain scriber will have a sharp point only on one end. Double-end scriber will have sharp edges on two ends of a scriber. One can draw thick lines on the surface of the workpiece by using a combination of scale and a scriber. Now, you are going to see about the other marking tool, punch. It is a tool used to make punch marks or light depressions at locations to be drilled. Punches are made of hardened steel with a narrow tip on one side. There are two types of punches, namely center punch and prick punch. The center punch will have an angle of 90 degrees at the punch point. The punch mark made by this angle will be wide but not very deep. The angle of the prick punch is 30 degrees or 60 degrees. The 30 degrees point prick punch is used for marking light punch marks needed to position dividers. The 60-degree punch is used for witness marks. When we keep this punch on the surface of the workpiece and hit with a hammer, an impression will be inscribed on it. Punch is mainly used prior to drilling operation. Now, you have learnt about some of the marking tools that are used in a workshop.
Measuring tools are extremely important because at the end of any machining process, it is necessary to verify whether the final product matches the prescribed dimension or not. Some simple measuring instruments include steel rules and tri-squares. A steel scale by itself can only measure length or breadth, but when it is used along with a stock, it we can also judge the flatness of surface. Let's go through the video related to this.
In this media, you are going to learn about the measuring tools used in a workshop. Measuring tools are used to check whether the product is made according to the prescribed measurement or not. Measuring tools that are used in a workshop are steel rule and tri-square. Let us see about engineering steel rule. It is the basic and most commonly used tool for measuring the length and drawing straight lines. These are made of stainless steel and coated with chromium to reduce glare and rusting. The only disadvantage is that we cannot get accurate result with a steel rule. Next, we are going to learn about tri-square. This is used for checking the right angles, angle of 90 degrees, of the side, and flatness of the finished surface of the workpiece. The blade is fixed in the stock at 90 degrees. The main parts of a tri-square are stock and blade. The blade is inserted into the stock such that both are in right angles to each other. Using a tri-square, we can even set the workpiece at right angles on work-holding devices. Now, you have learnt about some of the measuring tools that are used in a workshop.
Finally, let us talk about marking gauges. A marking gauge is a tool used for scribing straight lines that are parallel to the reference side of a workpiece. It consists of several parts: a headstock, a stem, a spur, which is a pointed steel pin, and a lock screw. To use it, adjust the headstock over the stem to set the required distance between the spur and the face of the stock. Tighten the lock screw so the measurements remains fixed. Then run the spur against the workpiece to describe a straight parallel line. In some modern marking gauges, the traditional nail or pin is replaced with a mortise wheel for smoother and easier markings. Let's end this session with a small clip related to the usage of marking gauge. So, my friends, we have now covered the entire topic of marking and measuring tools. Today we learned about marking is the first step of machining, measuring is the final step. Tools like vernier calipers, screw gauges, scabbard, punch, marking gauges play a crucial role in ensuring accuracy, and proper marking and measurements help achieve the correct dimension and a high quality final product. Thank you for listening, and we will continue with more practical application in the upcoming section. Thank you once again.